Hi guys. So like I said, I am gone today for class. So reminder that we took notes over these first three examples yesterday or on Wednesday during the block period. So we should already have those completed. If you were gone, your sub has copies of this worksheet, or if you lost it and you need another copy. But you should have this in front of you, and we should have already completed the first three. If you were gone for some reason, you can check in our student folder to see the completed work for these examples. But we're going to dive right into some more examples. Okay, so if we go to the back side, we got three more examples on here. You also should grab the worksheet. If the sub has not handed that out to you already, this video will go straight from these examples into some stuff on the worksheet that we'll have after. Okay. So reminder, this lesson is on piecewise functions. So a piecewise function is what we see examples of here, where for specified x intervals, we are graphing different types of functions for different parts of our graph. And this is what we started doing on Wednesday at the end of the class period. So let's go through the steps again. I think the best way to organize this is to have some different color or highlighter of some sort so that you can stay organized in terms of marking up your intervals and labeling on your graph what you need to graph where as your first steps. So personally, when I do these problems, first thing I'm going to do is I'm going to look at my intervals over here, and I'm just going to highlight those x values. So here our only x value is 0, upon which we're changing from this function of negative x squared to x plus 2 squared minus 6. Okay, so what I'm going to do is I'm going to go over to my graph, and I'm just going to highlight that x value of 0. Okay, so x is at 0. That's really our y-axis. Okay, and keep in mind I'm writing on my screen, so this could get a little messy, but you guys are going to want to be a little bit neater than what I can do on here. Next, what I'm going to do is I'm going to look at what function is where. So this top one is negative x squared, and that's for when x is less than 0. So that'd be this portion off to the left. So I'm just going to label above negative x squared. And then my function x plus 2 quantity squared minus 6 is for when x is greater than or equal to 0. So over here, for all of our positive x's, I'm going to label x plus 2 quantity squared minus 6. Okay. Strongly suggest use a pencil, like how you should for all of your math. But here, definitely use a pencil, because what our main method will be to graph each of these functions in its entirety and then erase what we don't need, because we really only want to graph negative x squared on this left side. We only want to graph x plus 2 quantity squared minus 6 on this right side. Okay, so let's start with negative x squared. Well, this is a parabola. This is what we graphed a lot last unit. Okay, we could graph this in a lot of different ways. We could make ourselves a table of values. We could recognize that this is in standard form. We could substitute in points. Okay, I would say probably the quickest way to graph negative x squared. We could substitute in some values real quick and get points. Okay, right? Like if we put in 0 for x, negative 0 squared is just 0. So this starts at 0, 0. So we could plot this point here. And then if we went 1 unit over and put in 1, negative of 1 squared, like this is saying negative 1 times 1 squared, well, that's negative 1. So we're at 1, negative 1. Well, we know this is a parabola, and we also know the vertex is really going to be at 0, 0 for this. So we could mirror this point over here. And we could do some more points. Maybe we put in 2. Then we'd have negative 1 times 2 squared. Well, that's negative 1 times 4. So that's negative 4. Okay. So negative 2, negative 4. 1, 2, 3, 4. And we could mirror that point over. Okay. We could do one more if we wanted. If we put in 3, we're going to get negative 9. Okay, so over 3, negative 9. Down here, can mirror that point over. Okay, so now we kind of have to figure out what we actually need out of this. So we only want to graph the x values to the left here. So we can draw in this part over here. let's erase what we don't need. We don't need these values over here. And then one thing to note is that this says for when x is less than 0. So not less than or equal to, when x is less than 0. So we can change this to an open circle, saying we're not including this point at 0, 0. Okay. So we just graph negative x squared for this left portion. Now on the right, x plus 2 quantity squared minus 6. Well, this is another quadratic that's in vertex form. Okay, so our vertex would be -2, -6. Okay, so again, even though that's off to the left, I'm going to graph it, and I'm going to get more points. And then I'm going to use that to create my sketch, and then just get rid of whatever I don't need. So -2, -6. Plot that point down here. Okay, and we could substitute in different values to get more points. And make ourselves a little t-chart. So if my vertex is at -2, maybe we put in -1 and see what we get. So -1 plus 2 would be 1. 1 squared is 1, minus 6, -5. So -1, -5. We could put in 0. 0 plus 2 squared, that'd be 2 squared is 4, minus 6, -2. So 0, -2. Plot that point. Could keep going. Maybe we put in 1. 1 plus 2 is 3. 3 squared is 9. Minus 6 is 3. 1 comma 3. Now, this is a parabola where our vertex is right here. So our axis of symmetry is x equals -2. We could mirror these points over, but we're seeing they don't really matter for us because we're really only concerned with this part of the graph off to the right because we want to graph over here. So we don't really need the axis of symmetry to mirror over points. And we can just draw in this portion of the graph over here. Because this one is an or equal to, we can keep the closed dot here, and then let's erase these points that we didn't need. Okay. So that's our piecewise function graphed. So now that we have the piecewise function graphed, we could look at the domain and range. Okay, so the domain, the x values that were defined for, well, this graph is going forever to the left. So it would start at -infinity. We keep going, we keep going. We got all these x values covered. We get to the x value of 0. We have an open circle here, but we have a closed circle down here. So we are defined at the x value of 0. And then we keep going. We're going to the right forever. Okay, so it's positive infinity. Okay. Versus our range. Well, bottom to top, lowest y value, it's going down forever to -infinity. We're going up, we're going up, we're going up. Open circle here, but covered by this portion over here, going up forever to positive infinity. Okay, so that's that example. Let's do a couple more. So we go down. All right. So again, first step, we want to organize our graphs. We know exactly what we're trying to graph where. So I'm going to use a highlighter, and I'm going to look for these different x values that we have intervals for. So we want to graph -1/2 between x values of -3 and 3. So I'm going to go to the x value of -3. I'm going to draw in a line there. Okay. And you guys might be able to do this a little bit neater than me. Okay. Then we want to go to the x value of 3. Draw in a line there. It looks like those are our spots where we're changing. Okay. So now let's label what we want to graph where. So it's saying between -3 and 3, we want to graph -1/2. So let's label the middle here as -1/2. Exactly when x is 3, so right at this value, we want to graph x squared plus 1. And then for all x values bigger than 3, so this portion further to the right, we want to graph x squared minus 8. Okay. All right, so let's start graphing. Okay, so maybe we start with the -1/2. Well, y equals -1/2 is just saying we want all of the y values to be -1/2. Okay, so that would be a line that would be horizontal. Okay, so -1/2 would be right between 0 and -1. So we could draw in a horizontal line right here at the y value of -1/2. And then because this is just a less than sign here and a less than sign here, neither are or equal to, so we need open circles in both these spots. Okay, so that one wasn't so bad. Then we have x squared plus 1 exactly at the x value of 3. Okay, so now we really just want to know what's the output, what's the y when x is 3 for this function. So let's put in 3 for x and see what we get for that x value of 3. So we'd have 3 squared plus 1, right, replacing 3 for x. That'd be 9 plus 1, so we get 10. Okay, so at the x value of 3, we got a y value of 10. So that would just be a point that we could plot. 3 comma 10, right there. And then lastly, x squared minus 8 for when x is greater than 3. Okay, like we did in the previous example, let's just graph the function, and then we can erase what we don't need. Okay, so this is technically, this is in vertex form or standard form, depending on how you think about it. Okay, like this is vertex form because this is really saying x minus 0, quantity squared, minus 8, meaning our vertex would be at 0, -8. So we could plot that point. We also see that because this is in standard form where the c value is -8. So next, let's get some points for it. Okay, so maybe we make ourselves a nice quick table, putting in some x's. So maybe we put in 1. If we put in 1 squared, that's 1 minus 8 is -7. Okay, so at 1, we're at -7. We kind of know going ahead, though, that we really want values that are way over here. Okay, so maybe we jump all the way to 3, right, because we're going to have to find that value. We put in 3. 3 squared is 9, minus 8, 1. So at 3, we're at 1. Plot a point there. We can keep going. Maybe we go to 4. 4 squared is 16, minus 8 is 8. So 4 comma 8. So it's going up quick from here. Okay, so we see this parabola taking shape in here. But again, we only are trying to graph x squared minus 8 for this portion over here. Since it's just a greater than, we're going to have to tweak this closed dot here and make it open. Okay, so let's put an open circle here. And then connect this point going up. Okay, and then we can erase these points that we plotted down here. So here's our piecewise function graphed. So now we have to think about our domain and range. Okay, so for our domain, we're thinking what's the furthest to the left this graph goes. Well, the furthest to the left this goes would be the x value of -3. And we don't want to include that value because we have an open circle. So we would say parentheses, -3. Then we keep going. We got all these points. We get to the x value of 3, open circle, so still not defined, but closed circle up here. So we do have an x value here, and then it keeps going forever to the right, so to positive infinity. Our range, we're thinking what's the lowest our graph goes for our y values, what's the highest? So lowest y value would be the y values we have here. And don't get confused by the open circles because we do have defined points all the way in between here. Remember that y value was -1/2. Okay, so we could say we just want the y value of -1/2 union, because there's more values. Notice it's not in between here, right? We don't have the values in between -1/2 and 1. Okay, then at the y value of 1, it's going up forever. Okay, and then since we have an open circle here at this y value of 1, we're going to use a parenthesis, 1, it's going up forever to positive infinity. Okay, all right, one more. this is getting us back to the types of functions that we've graphed a lot this week. Okay, let's start by highlighting our intervals that we're working with and labeling. So it looks like we just have x being 5 as what we are really working with. Okay, so let's highlight the x value of 5 right here. And then let's label our graphs where they are. So cube root of x minus 5 when x is greater than 5. So that would be these values over here. Okay, so cube root of x minus 5. And then when x is less than or equal to 5, we want the absolute value of x minus 2 minus 3. So all of this. Okay. All right, so let's just graph them. So if we graphed cube root of x minus 5, again, graph the whole function, then you can always erase what you don't need later on. Okay, so cube root of x minus 5. That would have a critical point at 5, 0. So we could plot 5, 0. And it's a cube root, so we can go up by our perfect cubes as we go to the right and left. So remember our perfect cubes, 1, 8, but then also -1, -8. Since there's really an a value of a 1 in front, we're just going up by 1 unit. Okay, so as we go 1 to the right, we go up 1. Then we go back to the beginning. So we go 8 to the right. This is going to go a little off our graph. 1, 2, 3, 4, 5, 6, 7, 8. Up 1 more. We could go to the left, right? We know a cube root function will go to the left, but we're really only graphing this portion over here for our cube root function. So we can draw in our curve, and you can do a little better than me. I'm trying to do this on my screen. Since it's just greater than, let's change our closed dot here to an open dot to reflect that we don't actually have this defined at that spot. So there's our cube root of x minus 5. Now we have to graph absolute value of x minus 2 minus 3. Okay, so our critical point this time where we're starting, 2, -3, 2, -3, right here. Remember, there's really a 1 in front, and that's acting like a slope as we go to the right and left. So we go up 1 unit, right 1 unit, up 1 unit, right 1 unit, up 1 unit, right 1 unit. We could keep going, or recognize we got to go back to the left also. So go left 1 unit, up 1 unit, right, up 1, left 1, up 1, left 1, and we can draw in our absolute value. Since this is the stopping point, we don't need to go further than that. And since it's an or equal to, line underneath, closed dot there. Okay, so that's the graph of our piecewise function. Now let's look at the domain and range. So the domain, the x values, well, this is going forever to the left. Okay, so we can say -infinity. We follow it, we follow it. We got all these x values. We're defined. We get here. We have one open circle, but one closed circle also. So we are defined here. We're still defined as we go to the right. It's all real numbers. It's every possible x value. Then as we think about our range, the lowest our graph goes, our lowest y value, well, that would be the y value of -3. And we do have a point there, so we'd use a bracket, -3. And then it is going to go up forever to positive infinity. Okay, we see that both here. This is going to go up slowly forever, and then also over here, it's going to keep going up forever. Okay? So that's what we need to be able to do. Okay, so we section off our graph, use a pencil, graph, erase what we don't need, be able to communicate domain and range after. What we have to do for homework independently is going to be the worksheet that you guys got. So if we take a look at that real quick, same process. Okay, section off your graph into its parts. Notice there what might be some gaps in some of these. So like if we looked at number 1, notice it says, here's our 2 linear functions this time. Let's highlight our sections. So we got -2 right here, 1 right here. So this one's saying when x is less than or equal to -2, so all these values to the left of -2, we want -x. And then when x is greater than 1, we want -2x plus 4. Notice there's not going to be anything in the middle here, and that's fine. So if we're graphing y equals -x, well, that's technically in slope-intercept form, right? It's like -x plus 0. So if we're going to graph this, again, use pencil so we can erase later. It would start at 0, 0, and has a slope of -1. So we go down 1, right 1, down 1, right 1, down 1, right 1. But really, we know we're graphing over here, so we want to go up 1, left 1, up 1, left 1, up 1, left 1. Since it's an or equal to, we can keep the closed dot here. We don't need these other points. Okay. Then we want to graph -2x plus 4, okay, for when x is greater than 1. Okay, so same deal, graph this and erase later on. So we'd plot our y-intercept at 0, 4. Slope's -2, so we go down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. It says x has to be greater than 0, or greater than 1. Okay, so here we'd want to erase our point here, change that to open circle. Draw on our line. And let's erase the starting point. So that would be our piecewise function graph. Okay, so completing the rest of this will be our homework. Okay, so you'll see a variety, right, like a quadratic, absolute value, a couple linears, absolute value, linear, okay, backside, quadratic, absolute value, horizontal line, quadratics, square roots. Okay, so there's a good variety in there. Okay, so completing the rest of this will be our homework. Okay, so have a good weekend. I'll see you guys on Monday.